All right, let's talk about something that trips up so many developers, the difference between hard and soft links in Linux. We're going to make this crystal clear so you know exactly when to use one versus the other. So let's kick things off with a question I hear all the time. Is a hard link actually a backup? It's a really good question, and honestly, it kind of seems like it should be, right? But the truth is a little more complicated. Let's dig in. Okay, so to really get to the bottom of this, we need to peek under the hood of the Linux file system. And everything, I mean everything, starts with this thing called an inode. So what the heck is an inode? The easiest way to think about it is like an ID card for your file. It's the real identity of your data. That file name you see, like file.txt, that's just a friendly label, a sticker that points to this ID card. The inode is what actually knows where all the bits and bytes of your data are sitting on the hard drive. Okay, so with that in mind, what happens when you create a hard link? You type in the command ln file.txt hardlink.txt. Now you might think you're copying the file, but you're not. Not at all. All you're doing is slapping a second label, hardlink.txt, onto that exact same inode. Now don't just take my word for it. We can actually prove this right here on the command line. The magic command is ls-li. That little -i flag, that's the key. It tells ls to show us the inode number for everything in the directory. And boom, look at that. When we run it, you can see file.txt has the inode number 12345. And right below it, hardlink.txt, it has the exact same number. That's the smoking gun right there. It proves they aren't two files, they are two names for one set of data. So, you might be wondering, how does the system know not to delete the data if one name is gone? Well, it's pretty clever. Inside that inode, there's a little counter called the link count. When you first create a file, the count is 1. Create a hard link, it bumps up to 2. Create another, it's 3. The system will only actually delete the data on the disk when that counter finally hits 0. Aha! And this is where that whole backup idea comes from, right? Because if you delete the original file, say you run rmfile.txt, all that happens is the link count drops from 2 down to 1. The data itself, it's completely safe. It doesn't get touched because hardlink.txt is still pointing to it. So yeah, it totally protects you from an accidental rm command. That's pretty cool. But is that the same thing as a backup? Not even close. And now we're going to see why that myth gets busted. I love this analogy. It makes it super clear. Imagine the inode, the data, is a joint bank account. The original file, file.txt, is your debit card, and the hard link, hardlink.txt, is your partner's debit card. Both cards are linked to the very same account. Now, if you lose your card, no big deal, right? The money's still safe in the bank. But what happens if your partner goes on a spending spree with their card? And that right there is the fatal flaw. Since both file names point to the exact same data, if you change the data using one of them, it's changed for both. So if you open up hardlink.txt in an editor and delete everything inside, guess what? File.txt is now completely empty too. You just drained the joint account. A real backup protects you from data corruption or accidental changes, and a hard link gives you zero protection for that. Okay, so if a hard link is like a sibling sharing the same DNA, what's the alternative? Well, that brings us to soft links, or as you'll often hear them called, symbolic links, or symlinks. And these are a whole different ballgame. Yeah, unlike a hard link, which is an equal, a soft link is more like a signpost, or maybe a shortcut on your desktop. It's its own brand new tiny little file, and all it contains is the path, the directions to the original file. It just points the way. And this is the absolute key difference. If you were to run that ls-li command again, you'd see that a soft link has its own totally different inode number. It's not another name for the same thing. It is a completely separate file whose only job is to hold the name of another file. And because it's a separate file, this leads to the biggest difference in behavior. What happens if you delete the original file? Well, your signpost is still there, but now it's pointing to an empty field where a house used to be. The link becomes a broken link. It's still there, but it's pointing to absolutely nothing. All right, we've broken down the theory. Now let's throw them in the ring for the ultimate showdown. Hard link versus soft link. So let's do a quick fire comparison. On the left, you've got the hard link. Same inode, it survives if the original file name gets deleted. But, and this is a big but, It cannot cross file systems. You can't have a hard link on one drive pointing to a file on another. On the right, the soft link. It's got a different inode. It breaks if the original is deleted. But its superpower, it can point anywhere you want. Across drives, across network shares, no problem. And for those of you who love a good table, here's everything in one place. We've covered the inodes and deletion behavior, but check out these last 2 rows, because for us developers, these are huge. You can't make a hard link to a directory, period, but you can with a soft link, and that is super useful for organizing projects. And then the command, it's so simple. The exact same command, ln, you just add the -s flag to make it a soft or symbolic link. Okay, I know what some of you are thinking. This is cool Linux stuff, but I live in a Windows world. Well, guess what? You've been using these concepts all along. They just have different names. You know those shortcuts you have all over your desktop, the ones with a little arrow? Yep, those are soft links. And you know how when you uninstall a program, the shortcut stops working? That's a broken link. Same exact idea. And Windows uses hard links all over the place, under the hood, especially to save disk space. And the cool part is, you can make them yourself with the mklink command in command prompt. So there you have it, hard links versus soft links. We've gone from the inode level all the way up to Windows shortcuts. And we definitely busted that backup myth. But now I want to turn it over to you. Let's get a conversation going in the comments. I've got a few questions for you. First, tell me about a time you actually used a hard link in a real project. I'm really curious about those use cases. Second, do you have another great analogy for explaining this? The joint bank account is good, but maybe you've got a better one. And last but not least, what's another confusing Linux topic you want us to break down next? Let me know. Thanks for tuning in.